Started on lesson 9. We're comparing graphs. So for 9.1, we have this graph shows the population of Baltimore and Cleveland in the 20th century. So B of T is the population of Baltimore in year T, and C of T is the population of Cleveland in year T. So let's first look up here and review what is our independent variable.
Shouldn't it be B? Wait.
Hold on 1 second. Let me get my thing to be. Oh, no, I'm just going to zoom in. Independent. Dependent. Okay. So what do you guys think the independent variable is going to be in this case?
B? Or is it B of T?
Neither of those.
Oh, wouldn't it be? Oh, Baltimore. Oh, no.
So your independent variable in both of these cases is time. It is the year. So time, oops, I'm going to do that in red and blue. It's time / year. That means my dependent variable is going to be the population, either Baltimore or Cleveland. So population B or C. Okay, so we're going to estimate B, so the population of Baltimore in 1930. So Baltimore is the blue line or the solid line on your paper. In 1930, what is approximately the population?
Around 800,000.
Okay, so B of 1930 is about 800,000. Okay, so this is the population. So explaining what it means. Population in, yep, the population in Baltimore in 1930 is approximately 800,000 people. All right. Here are pairs of statements about the two populations. In each pair, which statement is true? Be prepared to explain or show how you know. So on A, we're looking at the population between Baltimore and Cleveland in 2000. So Baltimore is right here. Cleveland is right here. Is Baltimore greater than or less than Cleveland? Is the population of Baltimore greater than or less than the population of Cleveland, according to this graph in the year 2000?
Greater than?
It's greater than. So because our population is up here, it's going to be more. So let's look at 1900. We have Baltimore in 1900 here, and Cleveland in 1900 here. Are those equal?
No.
No. Is there any point at which the populations are equal?
1910.
1910. Where else?
Between 1940 and 1950.
Yeah. Excellent. So is the population of Baltimore greater than the population of Cleveland?
Yes.
In 1900? Yes. All right. Oh, I already asked this question. So were the two cities' populations ever the same? Yes, they were. In 1910. And so let's see here. I'm going to go up here and mark this. They were the same right here. They were also the same right here. We're going to say
around 1943.
Yeah, let's say around 1943. And in 1943. Excellent job. Let's go to the next page.
See, this is a lot easier.
All right.
I remember. Okay.
All right. So 9.2, wired or wireless. So H of T is the percentage of homes in the U.S. that have a landline in year T. C of T is the percentage of homes with only a cell phone. Here are the graphs of H and C. Estimate the percentage of homes in 2006 that have a landline and the percentage of homes with only a cell phone in 2006.
Back then, landlines were the only.
Okay, so we're going to estimate the the homes with landlines in 2006. So we're going to go up to the blue line. What do you guys think that is?
That is at least
85. Probably about 85. I think that's a good percentage. Let's say about 85%, or we can just say 85. And then C, so only cell phones. House was with only cell phones in 2006. So C of 2006, what do you guys think that is approximately?
That would be about 80, 82. Wait, what?
15.
About 15%.
Oh, wait.
Okay, so to explain what this means, we're going to say in 2006, about 85% of homes had a landline, phone, and about 15% of homes only had a cell phone. You know what's crazy?
What?
I was one of the ones that only had a cell phone in 2006 because we didn't have a landline probably before 2004 where we lived at, because we built our house in 2004. So whenever we built our house, we never had a landline at our house. So we've always had cell phones since 2004.
Did any of your
What is the approximate solution to C of T equals 20? Explain what that solution means in this situation. So we're going to look for C of T. So I'm going to look equals 20. So I'm looking at 20%. About what year is it at 20%?
2008.
2008. So T is about 2008. And explain what the solution means. We're going to say it means that around 2008,
Were cell phones really expensive?
20%, hold on, of homes used only cell phones. Honestly, I don't remember how expensive cell phones were back then.
But they're not as expensive as the new phones.
They're not as expensive as phones are today, but if you account for inflation, like they were pretty expensive, except like most phones you got on a plan and didn't pay anything up front. So it was just, it's kind of like what you experience today when you go into a cell phone store or your network store and you go buy a phone and it's like, oh, it's this much per month. Just it was like way cheaper per month for a phone. And like in 2004 to 2006, I think I had one of those, the Motorola Razrs, little flip phones.
Oh,
I had
yeah.
that phone.
Moto.
I would play with that.
Determine if each equation is true and be prepared to explain how you know. So is C of 2011 equal to C of 2000, or H of 2011. I can't talk. So, are the number of landlines and the number of cell phones only the same percentage in 2011?
No.
No, why not?
Because. Sorry, my mind was just blank. I had a whole paragraph in my head.
No. It's just because the lines don't intersect. The lines don't intersect. C of 2011 is approximately 30% or 30. And H of 2011, I can't write today, 2011, is about 70%. So clearly those aren't the same number, right? So now let's look at C of 2015 and H of 2015.
Yes.
Yeah, because they intersect right there, don't they? So yes, because the lines intersect. I cannot spell. Intersect.
I have anxiety.
All right, hold on one second. So we have C of 2015 equals H of 2015, which equals, what is our percentage there? It's about 50? Yeah, equals 50. Okay, between 2004 and 2015, did the percentage of homes with landlines decrease at the same rate at which the percentage of cell phones only homes increased? So let's go up and look at that. So does it look like does it look like the landline decreased at the same rate as the cell phones increased? I mean, we could assume it's pretty close, right?
Yeah.
So we could just say it looks roughly like they did. But if we calculated it, do you think it would be the same?
Yeah.
I don't think it would be the same if we calculated it. Because if we look at right here to 2015, right? That's what we're looking at on this one. Yeah, 2004 to 2015. So if we look from about 90, I think it's a little above 90%, right? Let's say about 92% to about 50%. And from here we have, what do we want to say this is about? 7 to about 50%, right? So if we took our slope of that, we would have, let's see here, our y values go on the top, so 92 minus 50 over 2004 minus 2015.
I'm not gonna lie, we made a major jump when it came to phones.
We did.
Well, it was the computer in your pocket back then, basically.
The Mactops, or whatever they're called. The Mactops, the old computers. No,
The white box computers.
Okay, but let's finish this real quick. So we get 92 minus 50 is 48 over negative 11.
Yeah.
Right? Yeah. And then we get, so the slope is a negative, let's say negative 48 over 11. And I'll simplify that in a second.
Oh yeah, because if you have a negative at the bottom of the denominator, you can move it up to the top.
You can move it up to the top, you can move it to the side, you can move it wherever you want as long as you have a negative slope. Okay, so 50 minus 7 is 43 over 11. So if I ignore the negative signs, which one has a steeper slope? The landlines or the cell phones?
The cell phones? Oh wait.
Wouldn't it be the landlines because it's got a higher number on top?
Oh yeah, it would. Okay.
Yeah, that's what I'm thinking. So down here we could say just by looking at the graph, they appear to have, they are similar. Rates, calculating the slope. Reveals that the landline decreases at a faster rate than cell phone only homes increased.
Do we have to write all that down whenever we do an actual quiz?
If you need to explain something, I would like for you to. I'm going to let you guys go ahead and finish writing this down, but I'm going to cross out the "Are you ready for more?" because I'm just going to skip that. We're going to go to the next page when you are ready. All right. So on this next page, we're actually going to skip this whole page and then go to the next page. And we're going to skip the top part. Now we're going to do functions, F and G. So 9.4. Here are graphs that represent two functions, F and G. Decide which function value is greater for each given input. So let's look. F of 2 or G of 2? Which one's greater? G of 2. Okay, F of 4 or G of 4? They're the same. Okay, F of 6 or G of 6? Okay, and F of 8 or G of 8? F. Okay, so we basically just determined that by looking at F of 2 and G of 2. G of 2 is above F of 2, so that's why we chose that one. F of 4 is where the two lines intersect. F of 6 and G of 6, F of 6 is higher. Same thing with F of 8. F of 8 is higher than a G of 8.
Okay, I was confused on how you got.
So for number 2, we have, is there a value of x at which the equation f of x equals g of x is true?
Yes.
Yeah, what is that?
F of 4 and G of 4.
So f of 4 equals g of 4. Is there another place? What is that? 9. So at 9, they intersect again. So we can say f of 9 equals g of 9. And explain our reasoning, because that's where they intersect. So they intersect when x equals 4 and 9. Identify at least two values of x at which the inequality f of x is less than g of x is true.
F of 2.
Okay, so f of 2 is less than g of 2. So that was this point here. Pick another one. F of 3. That's also true. Are there any other ones that are true? 10, 11, and 12. So we could say for values of x that are less than 3, less than 4, because that's where they intersect, right? Any value that's less than 4, does that mean g of x is greater than f of x? When g of x is greater than f of x for values of x that are less than 4.
Oh,
Is that true?
yeah.
So from here to here, not including the 4. Okay? And then we can say from here, so x needs to be greater than 9. So another way you might see this in the future would be 4 is, let's see here, greater than x, which is, oh, no. You can't do that. Never mind. Ignore that. Sorry. Messed up in the brain on that one. There's something else we'll look at later where we will do something else with that. But for now, this. Okay. Next page is the summary. So you guys have practice problems to do on Canvas, and I will have your study guide put for tomorrow and Thursday. Sorry, tomorrow and Friday, and you guys need to start studying for your test. When you guys are at home for Thursday this week, you need to take quiz 3. And if you are an 8A student, then you'll take the quiz on Friday at home.